Alright, so let's understand this problem, friend requests 2, in which we need to find out which user has the most friends. So here we are given a table called request accepted, which stores all the friend requests that have been accepted, right? So each row in this table has two columns, which is the requester ID and the acceptor ID. This means that a friendship has been formed between these two users. Now maybe let's go through the example step by step. So we have the following data. User 1 is friends with user 2. User 1 is also friends with user 3. Similarly, user 2 is friends with user 3 and user 3 is friends with user 4. Now let's count friends for each user. Now user 1 is friends with 2 and 3. So total friends are 2 for user 1. User 2 is friends with 1 and 3. So again total friends for user 2 is 2 again. User 3 is friends with 1, 2 and 4. So total friends are 3, right? And user 4 is only friend with user 3. So total friend is 1. So clearly user 3 has the maximum number of friends, which is 3, and that's why the output will be this, right? For user 3, the number of friends is 3, which is the maximum number of friends in the entire data. So now maybe let's understand how to solve this step by step. Now over here, each row in the table represents a friendship between two users, right? A requester and an acceptor. Now here's the key observation. Friendship is always bidirectional, right? That means requester is a friend of acceptor and acceptor is also a friend of requester. So each row actually represents two connections. Now to simplify this, we convert the table into a single list of users. And we do this by taking all the requester IDs, then we take all the acceptor IDs, and then we combine them using union all, right? So this gives us a flattened list where each row represents one friend connection, right? Now after flattening, each occurrence of a user means they are connected to one friend. So if a user appears multiple times, it means they have multiple friends. Next, we simply count how many times each user now appears, right? And this gives us the total number of friends for every user. Finally, we return the user with the highest count. And we do this using top one after sorting in the descending order, right? So now maybe let's translate this entire logic into SQL step by step. So first of all, we create a common table expression called num_friends. And here we flatten the data by selecting requester ID and then union all with acceptor ID. And this converts our relationships into a single column of user IDs. Now on top of this flattened data, we group by ID and count how many times each user appears. And this gives us the total number of friends for every user. Then we simply sort the results in descending order of count, and then we use top one to get the user with the maximum friends, right? And now as we can see, user 3 has the highest number of friends, which is 3, right? So that is going to be our output. So now the key idea over here in this problem, if you see, is to convert a relationship problem into a frequency counting problem using union all, right? And this pattern is extremely common in SQL interviews, especially in problems involving connections, followers, or interactions, right? So that's it for this particular problem. And now I will see you in the next one. Happy coding.